Now let's go back to our friend molarity. No, let's do molality first. I lied to you. I know, I was just joking. I was like, haha, fooled you.
I came to school and I turned around just to make sure he wasn't following.
So yesterday, remember, we did a bunch of different ways in which we could talk about solution concentration. Who remembers what they were?
It was
mole fraction. Your homework was on mole fraction.
There's molarity.
We haven't done molarity yet. Mass percent and mole fraction was what you practiced last night. And tonight you're going to add, what was the other one we went over? Molality. Very good. All right, so molality. So how do you do, let's start with mass percent because that's easiest. Mass percent, if I asked you to find the mass percent, how would you do that? Mass of solute or whatever divided by mass of the solution. And remember we said it's in very good, times 100. Remember the solution includes the mass of the solute as well as the mass of the solvent. Now mole fraction doesn't really have a unit. We said that mole fraction is equal to the moles of one, whatever it is, over the total moles. So we could say N1 plus N2 plus N3, whatever it is. And that was mole fraction. What was molality? Remember we said molality is usually not a really commonly utilized means of description for a concentration of a solution. But so how do we describe what is molality? You said something over kilograms. No, it's moles solute divided by kilograms solvent. So make sure you realize that that's solvent, not kilograms solution. So if you have the moles of solute and you have the kilograms of solution, you would have to find the number of grams or kilograms of solute and subtract that from your solvent, or subtract that from solution to get solvent. Yes.
What was mole fraction again?
The mole fraction was the number of moles of whatever you're looking for, so moles of A over the total moles. So it would like N1 plus N2, because remember we said N means moles. So we're going to talk about molarity. Molarity is a more convenient way to measure composition. We said that molality wasn't really convenient because it gives you kilograms of solvent. If I asked you, Jenny, honey, if you're not even going to pretend to pay attention, will you please just leave? Thank you. We said that molality isn't really convenient because you tend not to measure like water as your universal solvent in kilograms. You're going to measure it in volume. So molarity is a more common way to do this. And when we talk about molarity, it's defined as the amount of solute. I'm going to make this a little bit bigger. The amount of solute in a given volume of solution. We'll get to it, Zach. So generally our solutions tend to be liquid, so this is the most common and useful means. When we do this, generally you're going to give something in brackets, that means concentration. Remember in biology we said going from a high to low concentration, and we always put the H or the L in the brackets. Those brackets mean concentration. It's most commonly used with molarity. So if something's given to you in brackets, you know that that is the concentration of it. So we can also define it as the number of moles, so as the amount of solute in moles per unit liter of volume. So you would write it capital M, that's going to be the unit for it, or molarity is equal to moles solute divided by liters solution. So that's your total volume. And so technically, I guess moles per liter is what it is, but we just write that as capital M. So if something was a 1 molar solution, it would look like that. And you can put it like that, and that tells me that that the concentration is 1 molar. We can also use this as a conversion factor because you're writing it as moles per liter. So we can use this as a conversion factor in stoichiometry. Let's practice doing one.
Yeah, so like what is it gonna like ask for? 'Cause you know, like it kind of.
We're going to do a couple practice ones. So it says calculate the molarity of a solution prepared by dissolving 11.5 grams of solid NaOH in enough water to make 1.50 liters solution. So remember, for molarity is equal to moles solute per liters solution. Now notice they told you that you have enough water to make 1.50 liters solution. So that's already going to be your bottom number is 1.50 liters. But you have 11.5 grams.
So you're gonna
Go from grams to moles. Perfect. How do I do that? How do I convert?
You say 1.5 grams of NaOH. Do math on the phone.
So it would be 22.99 plus 1.01 plus 16 gives you
22.99.
plus 1.01 plus 16.
I got 40.
And that's going to tell me how many moles. So how many moles of NaOH do I have? So how many sig figs do we need in our final answer? 3. When you're doing your calculations, always carry it out at least 2 past the number of sig figs. You don't cut it off until the very end. So if we need 3, so we're going to carry this guy out to 5. So it will be what?
0.288.
No, 0.2875.
75.
That's where it ends.
Okay, 0. Okay. Zach, so we said that we need 3 sig figs in our final answer. When you're doing your calculations, you're always going to carry it out till at least 2 past the number of sig figs you need, and then at the very end is when you truncate it or you cut it off to those 3 sig figs. So here's my number of moles of NaOH, and then I just do moles per liter. So I'm going to move you over here. So I've got, then I just do 0.28750 moles NaOH, and our solution we said is 1.50 liters. What do you end up with? 0.192 is what I have as well. So you end up with 0.192, capital M, that stands for moles per liter, NaOH. And because it's a concentration, I'm going to go ahead and put it like that.
Also, whenever we're doing molality, you should put the concentration.
Molarity.
Molarity.
Generally, yeah, you can. I mean, that's what it indicates.
How do you know that that's the concentration?
Because the concentration of molarity is moles per liter. Didn't you just find moles per liter, Zach?
Yeah, we did. Okay.
Calculate the molarity of a solution prepared by dissolving 1.56 grams of gaseous HCl in enough water to make 26.8 mils of solution. So what is our units for molarity? We said it's got to be moles per liter. But ours is not given to us in liters. It's given to me in milliliters. So convert. So how many liters is 26.8 milliliters. Just move the decimal 3 places. We can even do it the little kid way. Loopy swoopy. So you have 0.0268 liters. And, well, we don't have the number of moles. It's given to us in grams again. So what do we have to do? Go from grams to moles. So I have 1.56 grams HCl. I know that every 1 mole of HCl is 1.01 plus 35.45. So 36.46.
45. Oh, I did 10.
So how many moles HCl do I have? I'm sorry? 0.0 or 0.8?
Yeah,
0.04. I wanted to go out 2 past my sig figs. 0.0, okay, for 2, 7, 8, 7. Okay, and that's how many moles HCl I have. So now I just do moles over liters. So 0.042787 mole HCl. And what is the concentration of our solution? 1.60. So you would say 1.60 capital M HCl and put the little brackets around it. Let's do 2 more practice ones, and then we're going to take it up a step. Welcome. All right, let's do another one. Calculate the molarity of a solution prepared by dissolving 1 gram of ethanol in enough water to give a final volume of 101 mils. Ethanol, remember, is C2H5OH. That one is yours. So what's the first thing you're going to have to do? For molarity, it's moles per liter. So you have to convert 1.00 gram of C2H5OH into moles. Does anybody remember what the mass is from your homework last night? .08, I think. 46.08. All right. Which is how many moles? All right, now we have to convert we have 101 milliliters. How many liters is that? 0.101. So now I'm just going to put 0.021701 divided by 0.101. And what do you end up with? Capital M. So molarity is pretty easy to work with. So, but the fun doesn't stop there. We're actually going to use the molarity to help us determine the concentration of ions in solution. And so your homework tonight is you're going to practice doing molality and molarity calculations. Remember, molality and molarity aren't the same thing. What's the symbol for molality? Little m. Very good. So remember, the big M is molarity, the little m is molality. And you're also going to have to find the ion concentration in your solutions. So think about what happens when you dissolve an ionic substance in water. What happens to the ionic compound? It does break apart into the associated ions. So I'm going to write that here. So it breaks apart into those associated ions. What do we call that process? Does anybody remember? Starts with a D.
Dissolve.
Not dissolve. It's called dissociation. Remember, it dissociates. Because of the behavior of certain ions in a solution, remember we know that those spectators, when we did our net ionic equations, the solution's composition may not be accurately reflected by the concentration of solute before dissociation. So like we just did, the concentration of NaOH. That one's okay because it doesn't really have any subscripts. But some things are better. It's better if we look at the actual concentration of ions in solution that we're going to be working with. So give the concentrations of all ions found in the following solutions. You have 0.50 molar cobalt 2 nitrate and 1.50 molar iron 3 chloride, 0.255 molar sodium carbonate, and 0.010 molar aluminum sulfate. Now, you have to do some of these on your homework. Let's go ahead. I'm going to walk you through exactly how I want you to go through the process of answering those. So the first thing we have here is 0.450 molar, and it's cobalt 2 nitrate. How do I write that? CO, parentheses, NO3, 2. Okay? That's what you've been given. When we put NO3 into solution, how does it break down? If I were to ask you to write or to write the ionic equation of it, how would it break apart in solution? So you start with, you're going to have to do this again on your homework, CONO3. It's going to break apart into what ions when we put it in solution? I don't have one. CO, and what's the charge on our cobalt? 2 plus. So you would write CO2 plus, what did it break in? What's the other thing it broke into? NO3 minus. How many NO3 minuses do you have? 2. 2 NO3 minus. So really that CONO3 tells me for every 1 mole of CONO3 I make, I have 1 mole of cobalt 2 ions, right? And I have 2 moles of nitrate ions. Does everybody see that? We just wrote it into a regular old equation. So now I want to find out the concentration of the ions. Since it's already in molarity, I don't have to do anything else to it. I'm just going to set up a simple stoichiometric equation. So to find the concentration of my cobalt ions, I'm going to use my molarity as my, for dimensional analysis. It becomes my little factor here. I know that 0.50 molar really means I have 0.50 moles of CONO3 dissolved in 1 liter of solution, right? But I don't want to talk about it in terms of CONO3. I just want to talk about it in terms of cobalt. Well, in this case, I know that for every 1 mole of CONO3, how many moles of cobalt ions do you have? 1. Very good. 1 mole CO2 plus. So now this is going to give me the concentration in moles per liter of my cobalt ions. So you go through, and this one happens to be real easy. It's just 1 to 1, but you still have to show this work. You don't show the work, you don't get the credit. You'd end up with 0.450 molar CO2 plus, and that's going to be your concentration of the cobalt ions. So how am I going to find the concentration of the nitrate ions? The same way. So it's going to be NO3 minus, and I start with 0.450 moles CONO3 over 1 liter. In this case, though, I know that for every 1 mole of CONO3 I have, how many moles of nitrate do I have? 2 moles of nitrate. So what's the concentration of nitrate in this solution? I'm sorry? 0.900 molar CO3 minus. Does everybody see how we did that? Helios, you okay? Do you see how we did it? Okay. Do you want to do another one? Here we've got 1.50 molar iron 3 chloride. So now I have to, first thing you have to do is write out the formula. I have 1.50 molar iron 3 chloride. How do I write out iron 3 chloride? FeCl3. Very good. So the first thing I'm going to do is I'm going to write a little dissociation kind of thing. So when I start with FeCl3, I want to break it down. What are the ions it's going to break into? Fe3 plus 3 Cl minuses. Remember, this you're breaking into or dissociating into ions. If you don't show the charges on them, it's wrong. You have to break it apart into the ions. So now we want the concentration of iron and the concentration of chlorine. So it's just the same thing, 1.50 moles FeCl3 over 1 liter. I note that for every 1 mole of FeCl3, how many moles of iron do I have, iron ions? 1, so it would be Fe3 plus. And so the concentration of my iron is equal to 1.50 molar Fe3 plus. And your chlorine, 1.50 mole FeCl3 over 1 liter. The only thing different here is for every 1 mole of FeCl3, there's 3 moles of Cl minus. So what is the actual concentration of chlorine ions in solution? 4.50 molar Cl minus. This is important when you're looking at different chemical reactions taking place. Yes, ma'am?
When we're writing out like the Cl, stuff like that, whenever we get like moles or do that, we wouldn't put 3 Cl minus, we would just do Cl minus.
No, because we're just talking about individual chlorine ions.
Okay.
That's like when we have a combustion reaction and you make like 24 waters. You don't write at the end 24 waters, right?
Yeah.
So you just write water. So it's the same thing. It's chlorine ions, but we happen to have, for every 1 mole of reactant, we have 3 moles of chlorine ions as product. Let's do one more. Let's choose one of these.
0.01.
Yeah, last.
All right, 0.010 moles of aluminum sulfate. So if I have 0.010 molar aluminum sulfate. Ooh, how do I write aluminum sulfate? What's the charge on aluminum? No, aluminum is not 4.
Is there 2?
It is not 2. It is not 1. It's 3. It's 3. Aluminum has 3. What's the charge on the sulfate? 2. Thank you. So when you write aluminum sulfate, it would be Al2SO4 3. You know that you have a final exam coming up in a couple of weeks, and all of that nomenclature is on it, right?
How many normal tests do we have left?
Can we do a review for that?
One more test. We'll have 1 day, and that's it.
1 day?
1 day, that's it.
Sulfate is 2.
Sulfate is 2. It's always been 2, forever and ever. Amen. That's it.
And a nice study group that we're making.
All right, so when we do this, remember to find, I need the concentration of aluminum ions, and I want the concentration of sulfate ions. In order to figure this out, what's the first thing I probably ought to do? I probably ought to write out my little dissociation thing, right? And go ahead and write that up.
Different from dissolution.
Al2,
Is the dissociation
We call it dissociation when it's ionic substances.
Okay.
So we have 2Al 3 plus 3 SO4, bless you, minus 2. Bless you, bless
Is
you.
it okay if you write this 2 minus?
Yeah, it doesn't matter.
Okay.
I fluctuate.
I just wanted to make sure that I like.
No, when you go to college, just do it like your professor, though.
Okay.
Just whatever he likes, you do. So point,
Oh, I learned it this way too. That's so great.
0.00 moles Al2SO4 3 over 1 liter, because that's what my molar means. And for aluminum, though, for every 1 mole of Al2SO4 3, you have 2 moles Al3 plus.
So we have the showers.
Yes, sir.
Does it matter if you write, like for the 2Al3 plus 3SO4 minus 2, does it matter if you write the 3 and then the plus sign? Or like?
I don't understand. No, we just went over that. Are you talking about for the charge on the ion?
Yeah.
I said when you go to college, just do it however your professor likes it.
For you, does it not matter?
I don't care as long as you have the right charge.
Okay.
I mean, if you wrote down a 4 minus for like sulfate, I'd mark it wrong.
But for
Because
minus-
sulfate is 2, not 4.
For minus.
SO4.
It is SO4, but the charge is 2 minus.
But for minus 1, it's just a minus.
Mm-hmm. All right, then I'm going to set it up for my SO4 right now, 0.100 mole Al2SO4 3 over 1 liter. 1 mole Al2SO4 3 for every 3 moles SO4 2 minus. All right, so what is the concentration of aluminum ions? You said is what? 0.020 molar. And how about the concentration of sulfate? 0.030 molar. Very good. So even though the whole thing together has a concentration of 0.010 molar, if you look at the concentration of the individual ions, it's much more concentrated in ions than this solution is together. Now let's take a look. Let's see if we wrote it a day. I've heard it both ways. How many moles of silver ions are present in 25 mils of a 0.750 molar silver nitrate solution? So now we're going to have to use our molarity as a conversion factor. So the way in which I would set it up is, what are you given? If we're going to use molarity as a conversion factor, what's the quantity that you've been given? Well, that's going to be my conversion factor. So I don't want to use that one to set up my dimensional analysis. So that's a conversion factor. What is the other quantity that is not a conversion factor you've been given? 25 mils. But my conversion factor is moles over liters. So the first thing I'm going to do is convert that into liters. So I could say 0.025 liters over 1. I know that for every 0.750, there's moles of AgNO3 I have in 1 liter of solution. And if I'm just looking for silver ions, I know that 1 mole AgNO3 has 1 mole Ag plus ions. So do you see how we took that and we used that as our conversion factor? We've kind of put together the definition of molarity, used that for a conversion factor, our old school dimensional analysis, and the concentration of ions in solution. And so when you get through it, what's the concentration of silver ions in that quantity of solution? 0.018, you said 75, so it would be 0.0188 molar would be the concentration of silver ions in that amount. Molar. Moles per liter. Yeah, I know. It's still going to be molar solution.
Okay.
Yeah. Even we only did that because that cancels out the total number of liters that you have. So we're just talking about in that little solution. But if we blew it all out to moles per liter, that's how many it would be.
Okay.
Yeah. So let's look at this. We can also use molarity to solve for mass. We use dimensional analysis to help us find the mass of a solute based on molarity. So to analyze the alcohol content of a certain wine, a chemist needs 1.00 liters of an aqueous 0.200 molar potassium dichromate solution. How much solid potassium dichromate must be weighed out to make the solution? Well, we're going to start the same way. We're going to look for the number of moles of potassium dichromate based on molarity and go from moles to grams. Yep. So we're just going to take 1.00 liters of we said we had 0.200 moles potassium dichromate per 1 liter. And then I want to know the number of grams. Well, I know that 1 mole of potassium dichromate, oh crud, I don't even know the formula. What's the formula for potassium dichromate? No. It's K2CR407. Very good. Because dichromate was a polyatomic ion that you're required to know. And now that I know you don't remember, I'm going to make sure I use it on the final. And now I need to find the number of grams in that. So somebody go ahead and find out the mass of it. Anybody have the mass of potassium dichromate? Cr is a transition metal.
So 398.2.
398.2?
Yeah.
All right, go ahead and tell me now how many grams of potassium dichromate should he measure out when he's making his solution?
79.6.
79 point what?
64 grams.
So, but with 3 sig figs, 79.6 grams. K2CR407. Great job. And you know, this is actually how I make solutions for your labs. Is I do the simple dimensional analysis, and so it's actually a practical lab skill. If you go on to college, or even here, if you are the lab tech, you have to be able to do this to make solutions.